solar technology occupies a notable part in the evolution of power generation, considering that the sun is frequently acknowledged as the most abundant fuel source of renewable energy in the world. The Department of Energy also stressed that based on sunshine duration, the Philippines' average solar radiation is 161.7 watts per square meter, with a range of 128 to 203 watts per square meter. Likewise, majority of the world's population relies on energy, and the demand for it grows exponentially on a yearly basis. Expanding the energy resources is very essential in order to replace a portion of the ones consumed by the general public. In line with this, the proponents has emerged to a project entitled Transportable Solar Concentrating and Tracking Parabolic Trough Reflector for Higher Efficiency of Photovoltaic Module. Through the years, various projects have been developed by green engineering pioneers in the Philippines that harness renewable energy at its greatest potential. But then, despite all of these advancements, a number of power shortages and looming jump of electricity rates are still experienced in the country. Likewise, the Philippines' geographical advantage in solar power is not yet fully utilized and maximized. In connection to this, the proponents created an innovation that uses solar energy as a viable residential solution to the increasing energy demands of the people. The project does not only aim to lessen a part of the consumer's expenses and electricity bills, but also endeavor that it would serve as a catalyst for more projects that intensify the use of solar energy. The project is beneficial to common households and classrooms. It can supply a power of up to 100 watts, thus making appliances such as lighting bulbs, electric fans, and television could be supplied with electricity.
Ngayong linggo na mararamdaman ang unang bugso ng all-time high power rate hike.
Meralco customers should brace for higher electricity rates this month.
Simula na kasi po ang singilan nung tinatawag ng all-time power rate hike.
Considering today's situation, where exponential inflation of primary commodities costs is observed, powering homes for a fraction of the ones consumers regularly pay to electric companies could be regarded as a big help. Moreover, the system is cost-effective. The project utilized a parabolic solar reflector to induce higher concentration of solar energy collected in the polycrystalline PV cell. The said reflector is formed in trough shape, so the incoming plane waves traveling along the axis are converged toward the focus. An improvised secondary mirrorized stainless tube is incorporated to the system to dash larger amount of sun rays to the PV cell. In the solar tracker section, two cadmium sulfide light-dependent resistors are placed at the top of the solar panel. The LDRs are directly pointed at the sun, therefore no shadow is casted. If the sun moves, there will be shadow to one of the LDRs. When an LDR is covered with shadow, the tendency is that the system will move in the direction where the shadow can be avoided. The LDRs are now directly pointed at the sun again. Meanwhile, a PIC16F877A microcontroller is utilized in the system, which translates the voltages on each of the LDRs into digital values. The converted signals are then compared to the LDR's threshold value. If the accumulated output is less than the threshold value, the LDRs would prompt the DC-geared motor to move clockwise and counterclockwise in accordance to the sun's direction. Otherwise, the rotator would remain stationary. On the other hand, the DC output of the solar reflector's PV cell is translated to AC in the inverter section. The battery connected to it would serve as a generator, hence power could still be supplied to the desired loads even without the presence of the sunlight.